Well, thank you everyone for joining us. I'm Barbara, and we're here with Gary Cooper. Gary is a retired secondary science teacher, and he's worked in our office for several years now. So I'm going to go ahead and turn it over to Gary. Thank you.
Okay, thanks, Barb. I'm going to actually start off not by talking about Google Earth, but talking about one of the mapping lessons that we like people to start with. And we can go ahead and flip right to the computer here, and I'll just be talking over the computer screen that you'll be seeing, and then I'll be jumping over to Google Earth as well. One of the first mapping activities we like people to undertake is the one where they map their local community. And in order to do this, and this is going to be a quick review, about a third of the schools involved in the program have completed this, but we're still waiting for some others. And what we have done is provided satellite imagery of your communities. We divided it into different zones, and then we put numbers, letters and numbers with different structures in them, and then asked students to go out and identify what these features were, or to add features that may not be seen in the satellite imagery. And it wasn't just structures, but we also put things in like the, in this case here, the runway and a gravel pit and those kinds of places. And this is one of the lessons that's on the ATEP website called How is this structure used? And then on this page here, you would see the different codes. So 1A would be a lived-in structure, or maybe a 4A would be a medical services. And then when you complete it, you send it back, and then I end up putting this in a database essentially, and I tie your comments and the land use code into the imagery, and then we can make nice color-coded images. And in this case here, the transportation is in this sort of yellow color, residential areas are red, and then some of the municipality structures are in blue here. And again, this is on the Alaska or www.aktsunami.org website, and it's one of the lessons there. So just a quick reminder, I guess, to people who haven't done that. That's we would like to get those, and that's the starting point here. So I'm going to jump off out of that, and I'll go over to the ATEP website. And the satellite imagery that we are providing to each of the communities is also available on the website, and it's under student resources. So if you were to click on that, it will take you to another page, and it will have the satellite imagery, the topographic maps, and some other things, multimedia, DVDs, and books. And then clicking on that will take you to each of the communities, and you click on that, and what happens is the satellite imagery that we have will open up on Google Earth. And one of the ones I'm going to focus in here is Larsen Bay today, just as an example. So I'm going to go back over to Google Earth that I opened earlier, and something that I didn't put out in the early agenda was ways of navigating around in Google Earth. And if you've used it, you get familiar with this fairly quickly. But on the right-hand side of the screen there's this zoom bar over there, and you can move the plus and minus signs, or you can just move the slider there to zoom in and out and around the planet. If you just want to move it, the Earth around, you can use your mouse and you click and just drag it around. The other way to do that is to hit the little compass type looking thing here, and that will spin the Earth around, or you can move it up and down and that kind of thing. And if for some reason you wanted to put the north at the bottom, you just grab the N on the compass up here and it will spin it around. And if you want to tilt the Earth, you can tilt it up like that with this button, and you can bring it down with that one, or you can turn it clockwise or counterclockwise. Those are all pretty intuitive, and I'm going to get over here to Alaska here and zoom in a little bit, because there's some neat keyboard shortcuts that you can use. And if you really tilt the planet here, we'll tilt Alaska down here, and let's spin it around a little bit. If you just don't want to try to use the compass rose, you can just hit the N key on the keyboard for north, and that rights you, or excuse me, puts the north up. And if you want to be looking straight down on the Earth, you can hit the U, and that brings you up again. And so to do that again, and I'll just twist this all around here, there's even another one. If you hit the R key on it, it will right you. And those are three really handy shortcuts to use when using Google Earth. The other one, and I'm in one of the lectures coming up, Peter Wembley will be talking about and how the Alaska Volcano Observatory uses it, Google Earth, and sometimes using these shortcuts really help out. The other way you can turn things around is using the shift key and the arrow keys, so you can go shift and then hit the up and down keys to tilt you, or you can hit the shift and the left or right keys to turn you around. And I'll just hit the R key again to right us. And one that I learned fairly recently here is you can also hit the shift key, and if you use the right or left mouse button, you can use that to twist you around too. And if you hit the control key or you hit the option key on a Macintosh, you can spin around that way as well. So knowing some of these shortcuts can be pretty handy when trying to navigate around in Google Earth. The other thing that you might notice on the screen is down here at the bottom, there's a latitude and longitude down here, and it also gives you your eye elevation that you are viewing wherever you're looking at from. So let's get over here towards Kodiak here. And if you see here, it's giving me my latitude, longitude at the bottom left of the screen. It gives me the elevation of the terrain there, and over again on the right hand side is the eye elevation. Well, this is right now set for decimal degrees, meters, and the eye elevation is also set in meters. Well, we can change all of that. And under the, on a PC, it's under Tools, Options, and on a Macintosh, it's under the Google Earth menu in Preferences. If instead you didn't want to use decimal degrees, and instead you wanted to use degree, minutes, seconds, this is where you can change that. And if you wanted to show the elevation in feet and miles, you can, again, just click this radio button over here as well. And if I'll just click OK, I'll come back to the screen in just a second. But now if you look in the lower left, you will see the display is in degree, minutes, seconds, the elevations in feet, and your eye elevation is done in miles. A couple other things in there that's kind of useful at times too is this elevation exaggeration. And in the elevation exaggeration, the default is it is set to 1. But if you set it high, up to 2, something like that, and I'll zoom in here and I'll twist us around and I'll spin us around here. Oops. And I'll just zoom in here. What the that elevation does is it will exaggerate how tall the mountains look. And if I bring it back to a 0.5 or something like that, you can see how the mountains, the relative heights of the mountains drop. So if you're in a relatively flat area, you would want to maybe exaggerate it up to a 2 or something like that, or 1.5. And if you live in a real mountainous area, you may want to drop it down to, say, a 0.5. But the default, and I usually leave it at 1 or a 1.5, is a good one. It's a good idea to leave it at 1, because if you start to put Google SketchUp files in there, if your elevation is not set at 1, you will lose the buildings in them. So, just a few options that you can use. I won't go into the other ones right now. If we have time at the end, we'll see, because we lost a little time there at the beginning, we can talk about those. Well, if you're going to be trying to find some place in Google Earth, you could just hunt around and zoom around until you find it, but you can also type in where you're looking for in the search box up here. As I said, I'm going to go first off to Larsen Bay here. So if I click on Larsen Bay, it zooms me in there. And for those of you who aren't familiar where Larsen Bay is, it's on Kodiak Island towards the what would be the southwest part here. And you can see how Google Earth imagery can vary here. And on the right hand side, it's pretty high resolution here. But you see right in the middle of this scene here, it's pretty coarse resolution over here. Well, on the ATEP website that I was pointing out, I said that we could just download the imagery that we provided, and I downloaded this before we started today, and if I'll just go ahead and click on it right now, this is what we provided to Larsen Bay, and you can see it's much higher quality than what Google Earth had. And you can go down also here. I should be able to, let me see if I can get this. Well, I'll do it a different way here. Maybe. I can change the amount of opacity of it. And let me drop this down here. And you can compare. Again, that's what Google Earth had there. And then that's what we provide there. So I'll click OK there, and there it is. Usually there's a slider at the bottom. I lost it there for a second. So let me see if I can just do it right from here. And so for your community, it's worth going to the ATEP website and downloading the imagery that we have made available to you. But since we've started the project, Google Earth has updated some of its imagery as well. So there's maybe better than ours is today, or what we have may be better than what Google Earth has. You just need to check it out for your individual community. One that's kind of a place here I'm going to go over to is Danger Bay. And I know you can't see us, Danger Bay, but you'll see this on the video. Mr. Clark, the teacher there at Danger Bay, he and I have been exchanging emails. We're trying to get some imagery of Danger Bay. And I was having trouble. I actually sent him a tile, and you can see a runway up here, and it was this area up here. When we were looking for it, we thought the school and the community would be around there, and he said, no, we're south of there. And so I said, well, could you send me the coordinates? And he sent them to me, and I could see, okay, well, this is where the coordinates lie, but I don't see really a community there. And so there, and we'll send this website to you. There is a through the statewide digital mapping initiative, they have what's called the best data layer, and they will have a file that works in Google Earth that will have the best imagery that the statewide digital mapping initiative has. And once I clicked on that layer, then I could see exactly where he was talking about. And again, this is what the GINA has, or the Statewide Data Mapping Initiative, and this is what Google Earth has. And so we're getting a good copy for Danger Bay there, and there eventually we'll have something better than what Google Earth has. And so this is a handy link to have if you're looking around Alaska in particular, because sometimes it's better than what Google Earth has. Okay. Something else here. I think I'll go over to some of the measurement tools in here, and I'll use Akiak for an example here. Akiak is a place that was hit hard in the 1964 earthquake. I think the run-up in this area was in the order of 18 meters high. And let me turn off the name here. And since we started this project, the imagery that Google Earth has provided it's one of the ones that has been updated. And what I was going to show you here is how to use the measurement tools in Google Earth. And at the top up here, there's a ruler up here. And when you click that, this little dialog box pops up. And so if we wanted to know the distance from the school to the ocean here, we'll do this in feet for now. What you can do is click on the school, and then you click on the ocean, and then it will tell you your distance, in this case at 800.86 feet. If you wanted to put that in kilometers, you just hit the little dialog box here, the drop down box, flip it over to kilometers, and it would be 0.24 kilometers. And it has all the centimeters, meters, kilometers, miles, nautical miles. But here's a real interesting one down here. This one's called smoots. And smoots is one that not many people know about. And this is it's a funny one. A smoot converts to 5.7 feet, and it's just kind of a, I don't know why Google Earth put it in here. It's just I guess an inside joke on their part or something. But Oliver Smoot was a fraternity student at MIT, and they flipped Oliver Smoot end over end on the Harvard Bridge and determined the Harvard Bridge to be something like 317 smoots long. And he's sort of immortalized now in Google Earth for having done that feat, but it converts to 5.77 feet. So not a very useful measurement, but that's why it's there. Usually you'll do things in feet. The other thing you can do with the ruler in terms of measurement is to make a path. So if we wanted to know how far it was, say, to the school, to the runway there, you can click on a line, click on the school, click on this intersection, and if you're going to be taking the road here, I'll do this sort of quickly, you can make a segmented line out of this. And I have been having a little trouble getting my paths to work today, but it will tell you then how many feet it is if you followed that path there along the road there. So that's also a handy feature that's built into Google Earth. Now I'm going to totally back away from this and zoom way out so we can see the whole Earth. Well, I think I talked about this in last year's presentation. You can put the grid on Google Earth, and I'll hit the N key to get the north up. And these are the grids of latitude and longitude. It's handy if you're just learning about latitude and longitude, but I find they kind of clutter up the screen. But something that's kind of interesting with the measurement tool here, and I'll click it back off again here in a second. If we zoom in here to Japan over here, and let me click on places here, and I'm going to click this off. I wanted the names to show up. Not sure why it's not. But I was looking for Tokyo here, but it is roughly in this neighborhood right here. And if we were to follow this all the way around to the United, well, let me put it back on for a second. If we follow this all the way around to the U.S., it would roughly be the same latitude as Washington, D.C. is. So if we were going to measure the distance between Washington, D.C. and Tokyo, see if we can do this here, we would click on our measurement tool, click on our line tool, and we'll click over here. Got that right. Let's see. I should be able to see a line happening here. There we go. And I'll zoom over here about to Washington, D.C. Let's see if I'll click that grid back on again here. You see that it doesn't follow the lines of latitude. It takes the shortest route here. If we were to follow a line of equal latitude, you would actually end up going, let's see if I can do this again. Maybe this path tool is not going to work here. Well, I'm not going to wrestle it here, but you would follow along here, and it works out to be about 1,000 miles farther to follow lines of equal latitude. And in the old days, it would be a safe way to navigate. If you were in Tokyo, you want to get to the west coast there and on over to Washington, D.C., you could just follow your compass due east. But with GPS technology and the way Google Earth calculates things, it will take you the shortest distance. It's sort of the over-the-pole idea. And you can see how that works by using the measurement tool, the line tool, and the ruler in Google Earth. So that's It's kind of neat how that works, and you can compare the two distances. Google Earth will always go by the what's called the Great Circle distance, and if you were to do that uh, on lines of longitude, they would work out to be equal. Okay, let me get rid of the grid, and let me get rid of that line taking us across there. A feature up at the top up here, I'm not the one on the right here. You can switch between the sky and the Earth. If you're into astronomy, that's one to check out, and I'm not going to talk about it today. The other one over here is kind of interesting, and it shows the sunlight, where the sunlight is on the U.S. or around the world. And if you move this forward, right now it's about 2:15 here, and so over here you can see how close we are to having a sunset here. And as we move this forward here, you can see then how, about right in here somewhere would be our sunset around 7 o'clock tonight. And then you can keep this going, and you can spin around and see that. And if you zoom way out there too, you can follow this all around the Earth there. Okay, some of the features, let me turn the sunlight one off here. One of the things about looking at satellite imagery is it's sometimes pretty tough to see. You look at something on the satellite imagery, but it's tough to connect it on the ground. And Google Earth has put a number of things in there to help you out. I'm zooming into Kodiak right here. And one of them is content that's been provided by users of Google Earth, and it's called Panoramio. And so if you're looking, here's a Kodiak, and you can zoom way in. If you click on some of these Panoramio shots, they'll show you what these areas look like from the ground. So this is the waterfront of Kodiak. The next one is channel fog from Kodiak. And so it's kind of neat that it gives you an idea of what these places look like from the ground. And there are thousands upon thousands of Panoramio shots. And if you have a photo, you can just go to the Panoramio website, register on it, you georeference where the photo was taken or what the photo was taken of, and it will be uploaded for anybody to look at. I'll go down to another one here. Let me go down to this one called 3D Buildings. I'll stay here in Kodiak for a second, and if we flip Kodiak on the side, it shows you what the terrain looks like there. And in fact, you can toggle this on and off with the terrain button. This is taking the elevation out of it and putting it back in. But you notice if we look at any of the buildings there, you don't see any elevation with them. All you have really is a satellite view of what their roof looks like and where they are located. Well, I'm going to zoom over here, and I looked here earlier to Hamburg, Germany. And Hamburg, Germany has some of the highest resolution imagery. Google has it. There's a place in Ireland that has very high imagery. And what Hamburg has done, if you click on these 3D buildings here, is they have made Google SketchUp files of the city center of Hamburg, Germany. And so as you look at this, and it takes a pretty fast connection to do this in a reasonable amount of time, but if you click on here, and you can zoom all around in here, I'll back out a little bit here, they have made 3D models of all the buildings, complete with what the front of the building looks like and everything. And just to show you the comparison, if you click off the 3D buildings, that's what the Google Earth imagery would be like. And if you click it back on, then that's what it looks like. It's a lot of work involved in doing something like this. And one of the files that is going to be posted on the ATEP website soon. We'll be using Google SketchUp and how you go about putting a building in there. It's not nearly as elaborate and detailed as these buildings would be, but you'll get if you follow the tutorial through it, you'll get a chance to try Google SketchUp out. So let me go back to Fairbanks for a second here, Fairbanks, Alaska. And this is something that Google put in to Google Earth in April of 2008. So this is fairly recent that they have done this, and it's called Street View. And they have a car, I guess is how this works, that they drive around, has a lot of cameras on it, and they take a bunch of pictures of places, and then they put it in what's called Street View. For Alaska, it's only done for Juneau, Anchorage, and Fairbanks. So this is where we are located right now, and we're in this building. If you can see my hand down here, this is where we are broadcasting from. Normally we're over in this building over here, if you can see the hand moving around. There we go. So if I flip this around, this is the building, this is the Geophysical Institute at the University of Alaska Fairbanks, and this looks like it was taken in the fall. And then this is the Butrovich building, and we're at the opposite end of this building here. Street View has actually come under some criticism. There are communities that don't want Google to have a Street View of their community, and there was a case where they had to take some of the street views off because they accidentally had traveled on a private road to get some of the imagery and things like that, I guess. But it's kind of neat. I was trying to figure out when these pictures were taken by looking at gas prices earlier, but I really couldn't figure out when it was done. I think it was the fall of 2007. Okay, let me go through some of these other ones here. Just maybe a comment I should have started with. When you're using Google Earth, it's usually a good idea to keep all of these things over in the layers turned off. If you turn them all on, it will really bog things down. And so as a general rule, I will leave everything turned off except terrain. A lot of times I'll leave the borders and labels turned on, so they don't take a lot of bandwidth to use it. But if you turn everything off, it will definitely start running slower. A couple other ones I was going to show you here for Alaska. I'll zoom back out, and this is under the gallery that they provided, and they have what are called gigapan and gigaplex photos. And I'll turn on the gigapan photo here. There's only one in Alaska. There's a lot more of these in the lower 48. And the only gigapan photo is of Skagway. There's a gigaplex, it's a high resolution photo, and then the gigapan one. And I'll zoom in here a little bit, turn this around. And then I can fly to this ultra high resolution panorama. And so when I click on here, it works a little bit like Street View. I'll zoom out here just a little bit. And then you can pan around here, and they've placed this image right into Google Earth. And what's interesting about this one, the reason I wanted to point it out, is the last fatality due to a tsunami in Alaska occurred in Skagway. It was in November of 1994, and it was an underwater submarine landslide that produced a pretty good sized wave, caused a lot of damages to the docks, and the wave bounced off part of the Skagway River delta that was under the surface of the ocean over on this right hand side over here. And then I'm not sure where the person was, but they were on one of the docks out here. So hopefully there will be more of the gigapan and gigaplex photos that Google will be adding. And you can really see the difference in the quality of the imagery. It's a very high resolution imagery there. A couple other ones that are interesting to look at. NASA has one that's the Cities of the Earth at Night. And you may have seen posters like this. And if you look at Alaska here, get us turned around here, you can see the populated areas in Alaska. And if you look at the lower 48, you can see the major cities down there. And if you spin around the Earth here, go over to Japan here, and you can see the major industrialized areas there. And the one that's they always point out in this type of imagery is looking here at the differences between South Korea and North Korea. Very different. That's not blacked out or anything. It's just there's not as many lights there. They aren't as industrialized as South Korea is. And then if you keep going around here, oops, go the other way, you can see some of the deserts. If you look over here in Africa here, not so much. So that's kind of a fun one to look at there. One I'm going to click on here too. This is the historical maps. And if you're, we'll go back over here to Alaska, zoom in here. How are we doing on time here? And I'll lay this one over here. You can click on this, and there's a bunch of the historical maps that they have made available. And this one is from 1867, if I remember right. Right, it's down here. And so if you zoom into your community here, and you can use this transparency slider here, you can compare the map of 1867 to what Google Earth has available now. And you can look at the different places. If you go up towards Anchorage, for example, you can see Campbell Point here by Campbell Creek. They call it the Cook River instead of Cook Inlet. And it's just kind of fun to look at some of these old historical maps. And you can see here's Carlick here, but it's spelled differently than we spell it today, and so on. So let me click off of this, and another one you might be interested in looking at is the volcanoes of Alaska. And I clicked on this layer here, and again, this is in the gallery section here. Next time, Peter Wembley will be talking about, again, how the Alaska Volcano Observatory uses Google Earth. But this is also a layer that's provided, and if you click on any of the volcano icons here, it's from the Smithsonian. It will give you a lot of information about that particular volcano and a photo of it. So it's a neat one to look at. So if I can click on another one here. Oops. Maybe. There it goes. There it is. So if you're studying volcanoes, it's a good site to look at. And the other one that is in here is earthquakes. And you can click on these. Actually, the USGS has a site too that has all the current earthquakes over the last 7 days. These have a lot of the larger historical earthquakes in here. And of course, it's the earthquakes that will trigger the tsunamis, and so this is one that is used a lot, or could be used a lot to help with tsunami prediction. And to close maybe this part out is that Google Earth itself is roughly was launched about 2006. It was originally made by a company called Keyhole Incorporated. It was called Earth Viewer. Google bought them, and they renamed it in 2006. So within the course of less than 3 years, it's really become a popular program, and more it's being used for the display of scientific information. So with that, I think I'll stop, and we'll give time for questions and go from there.
How old is Google Earth?
Well, how old is Google Earth is the question. Yeah, originally it was started Google bought it in 2004, so there had been work done prior to that. and it was called Earth Viewer, and that was done by the Keyhole company. And so Earth Viewer probably started, I'll roughly say 2002 or 2003. Google Earth renamed it Google renamed it Google Earth 2006, and it was, I think, released at the beginning of 2006. We're in 2008, so roughly, it's getting on its 3-year anniversary. It compared to things like word processing programs or web browsers, it's very new compared to a lot of those programs that have been around 10 or 20 years.
How many volcanoes is there?
Oh, that'd be a real good question for Peter Wembley, who will be here next time. He works with the Alaska Volcano Observatory here at the Geophysical Institute, and he would have a better estimate than I would.
When did they start? When did you guys start being on Google Earth?
When did we start being on Google Earth? Well, we put satellite imagery for the ATEP website on there. Was this 2008? I guess 2007 maybe, but and the Alaska Volcano Observatory, I think, probably did it in late 2007. I'm guessing, but we aren't one of the featured layers that Google has. You have to go to our website, and then in order to put it into Google Earth. And when I'm saying featured content, if I look down here at, let's say, the global awareness one, these are places like Greenpeace and Jane Goodall's, Greenpeace and Jane Goodall's chimpanzee research and things like that. These are ones that Google hosts, and we don't have anything on there that is hosted by Google, if that makes sense. You have to go to our website, you download something, and then I'll put it in Google Earth.
Just a quick question. When you were going through the tools at the beginning,
Yes.
could you just review what those were under again, up in the title bar?
Yeah, it's under Tools and Options. And if you're on a Macintosh, they're under Google Earth Preferences. And if you click on that, again, I'm on a PC, so this is Google Earth Options. I think it says on a Macintosh, Google Earth Preferences. Then there's a variety of things you can change in here, but probably the most common one is the lat-long elevation and feeder meters, and then the terrain exaggeration. The other,
I've got a quick question from Old Harbor.
Yeah.
Our students had to go to another class, and I was wondering, would they be able to email any questions that they came up with?
Sure.
And any time you can get a hold of Gary through ATEP website, we can forward the emails to Gary, and then Gary can write you back. And it's atep@gi.alaska.edu, the email address. And going back to volcanoes, Glenda found on the Alaska Volcano Observatory website that there's over 130 volcanoes in Alaska.
This is pretty fast going through Google Earth here, but hopefully I pointed out that there's lots of information available. It would take days to go through everything with Google Earth, but there's lots of ways you can navigate through it. There's different ways of looking at structures, features on the ground, and there's a lot of, again, just information that's available. So hopefully you'll take some time to work with our mapping project and some of the mapping activities, and we have some lessons coming up that'll be posted soon with looking at earthquakes and tsunamis from the National Geophysical Data Center. We have some lessons already posted on how to use Google Earth, how to put place marks into Google Earth, put photos in those place marks, and that type of thing. And so you can add a lot of your own content or get information from Google Earth. So hopefully it's piqued some interest in different ways that Google Earth could be used for you.
When you look at a volcano or a mountain, does it say the name of it?
Does
You
it say
see-
the name of any volcano when you're looking at it?
If you click on the volcano layer, let me get down there, and you click on it. So we'll get down to some of these down this way here on the chain.
Yep.
It will, when you just put your mouse over the volcano, it will tell you the name of it. And then if you click on it, then it will give you more information about it. And you can see, when you say 130 some,
It's it,
and
over
you can
130.
see all the volcanoes. What I was always surprised at is I didn't realize there were as many out here on the west coast out here. But certainly along the Aleutians, there are a lot of volcanoes out that way.
Does it show underwater volcanoes?
Does it show?
No, it doesn't. Actually, no, it doesn't show any of the underwater ones is the short answer. But what's been kind of interesting is that I guess it was last year they added what essentially they called Google Sky, and I didn't show that to you today. That was that icon that was at the top, and I'll show you what it looks like here. You flip around and it looks you see what would be the stars above you. So, you have to go through this tour first. I haven't done it on this computer. But there's been some talk about, or rumors, I guess, about there being a Google's Ocean. Instead of Google Earth, it would be Google Ocean. And I think that would be, if they do that, that will show a lot of the undersea volcanoes, coral reefs, different bathymetry, and that type of thing. Because right now, if you use your mouse and you go over the terrain, you can see the elevation in the bottom of the screen there. But if you go to anywhere on the ocean, it just remains a 0. And I suspect if they do release a Google Oceans, then you'd be able, when you mouse over it, you would see the depth of the ocean at that place. And again, all these features that you're talking, like undersea volcanoes and those kinds of things. So there's been nothing official by Google, but it has been rumored by, there's a blog that I read called Google Earth Blog that had mentioned it at one point. So.
Is because the volcanoes look in the water, is that because there's land underneath the water that you can't see?
Exactly, right. And yeah, and they're just, if they were to grow a little more, they would eventually emerge out of the ocean. For example, in Hawaii, there is a volcano that's growing now called Loihi, and I know it's thousands of years they figure, but eventually Loihi will be above sea level. And it's just, the ocean is, it's just still above it. But definitely there are undersea volcanoes.
Can you look at other planets?
Anybody?
Can you look at the planets?
Oh, in the sky?
Can you look at other planets?
Yeah, I believe you can. I have not spent a lot of time with Google Sky, and I'm not the best one to probably. I don't know much about the Sky one, but if you click on it, and if you look down at the lower left down here, there is probably some place in here, and if you clicked on these, it would show you images of these, and where its location is, and so on. But it's a little bit, what's tricky about it is knowing where you are. That's why I clicked on Fairbanks quick, so I'm not sure if that's even a look directly above head or not, but you can use the time slider here. And there is information about planets, but I just haven't used the sky feature as much. So.
Thank you.
Thank
You're welcome.
Thank you, Sandpoint.
Thank you for joining us.